The lone traveller drifts further into the velvet dark, leaving behind the familiar warmth of the inner sanctuary. The sun, once a tyrant of heat and light that dominated the sky with an oppressive golden hand, begins its slow and inevitable retreat. It sheds its identity as a blinding furnace and shrinks, transforming into a cold, piercing spark against the backdrop of the eternal night. The radiance that once defined the existence of the rocky inner worlds, the scorched iron plains of Mercury, the suffocating carbon clouds of Venus, the vibrant sapphire oceans of Earth, and the rusted silent deserts of Mars, is now a fading memory. Behind the traveller, these worlds have become nothing more than specks of dust caught in the solar glare, flickering briefly like fireflies before being swallowed by the immense looming shadow of the outer system. Between the last of the rocky outposts and the first of the gas giants lies a gulf of space so vast that the very concept of distance begins to lose its meaning. This is a realm of absolute silence, a vacuum so profound that it feels heavy against the hull of any vessel daring to cross it. Here, the light of the sun takes tens of minutes and then hours to traverse the emptiness, arriving weak and diluted, stripped of its power to warm or to nourish. The solar wind thins to a ghostly breeze, and the gravitational grip of the inner system loosens, surrendering the traveller to the territory of the outsiders. We're entering the realm where the giants rule, where the architecture of the cosmos is built on a scale that dwarfs the human experience. But while the gas giants themselves, Jupiter, Saturn, Uranus and Neptune, are the undisputed masters of this domain, their true value lies not in their swirling tempestuous clouds of hydrogen and helium. The real secrets are held by the diverse retinues of followers that trail in their wake. These are the moons, the silent sentinels of the dark. For centuries, the human gaze was fixed upon the planets, those wandering stars that commanded our myths, our calendars and our maps. We saw the moons as mere afterthoughts, dead rocks trapped in the eternal service of greater masters, insignificant mirrors reflecting the borrowed light of a distant star. Yet, as we move deeper into the cold reaches, a fundamental shift in perspective occurs. These small, frozen outposts are not secondary characters in the celestial drama. They are the true protagonists of the cosmic story. These moons are living archives, their surfaces scarred by the history of 4 billion years of solitude. Within these spheres of ice and stone, the secrets of the early solar system are preserved in a state of deep, cryogenic freeze. While the inner planets have been churned by the relentless engine of plate tectonics, eroded by the persistent hands of wind and rain, and fundamentally altered by the chemistry of life, these distant satellites remain largely unchanged since the dawn of the sun's reign. They are the witnesses to the birth of the planets, the survivors of a chaotic era when the heavens were filled with fire and debris. To look upon their surfaces is to read a ledger of the ancient past, a record written in the language of craters, ridges, and frozen oceans. The scale of the silence between these worlds is an entity unto itself. It is a distance measured in hundreds of millions of miles, where the rhythmic heartbeat of a robotic explorer is the only sound in a void that has known nothing but the passage of light for eons. The traveller moving through this space must abandon the intuition of the inner world. There is no horizon here, no sense of up or down, only the relentless invisible pull of the giants and the faint reflected glow of the sun on distant rinds of ice. As the first of these great systems begins to loom, the majesty of the gas giants fills the field of vision, but it is the small, flickering lights orbiting them that demand our attention. This is the story of the outsiders, the strange and defiant worlds that exist at the edge of the abyss. It is a narrative that breaks the rules of geology and chemistry as they were established on our warm terrestrial home. In the outer solar system, the very elements change their masks. Water ice becomes as hard as granite, forming mountains that reach toward the stars. Methane and ethane, gases on Earth, flow as liquid rivers and pool into vast, dark lakes. The definition of a world is challenged and expanded by these satellites. We encounter spheres that should be dead and frozen but are instead alive with the scream of volcanic fire. We find worlds that should be dry and barren but hide global oceans beneath shells of ice, seas that contain more water than all the basins of Earth combined. By shifting our perspective away from the sun, and toward the cold dark, we begin to see that the potential for complexity and the spark of life are not confined to the inner circle of warmth. The moons of the outer giants are not just companions, they are laboratories of the extreme, where gravity acts as a sculptor and tidal forces provide the energy that the sun can no longer give. They are the outposts of a new frontier, reminding us that the universe is far more diverse and far more resilient than we once dared to believe. As the traveller looks back one last time, the inner planets are lost in the glare of a sun that is now just another star among millions. The journey into the dark has begun, and the silent sentinels are waiting to tell their tale. The story of our understanding begins in the winter of 1610, beneath the biting frost of a night in Padua. Galileo Galilei stands alone, his hands numbed by the chill as he clutches a crude tube fashioned from wood and leather. Inside this humble instrument sit two small discs of glass, ground by hand and polished with the hope of bringing the heavens within reach. He turns this glass eye toward the wandering star of Jupiter, a beacon that has commanded the night for eons. At first, the giant planet appears as a small luminous orb, but as he steadies his gaze and clears his vision, something impossible emerges from the darkness. 3 tiny points of light, sharp and unwavering, sit in a perfect line across the middle of the planet. Night after night, the observation continues, and the stars do not behave as stars should. They do not fall behind as Jupiter marches across the celestial tapestry. Instead, they dance. They move from one side of the giant to the other, sometimes disappearing behind its bulk or vanishing into its shadow. By the 13th of January, a fourth attendant reveals itself. These are not distant suns residing in the deep background of the cosmos. They are companions. They are moons. In that single moment of clarity, the hierarchy of the universe, a structure that had stood for 2,000 years, begins to crumble. The Earth is no longer the unique solitary centre of all motion. If Jupiter has its own retinue, then the geocentric model, the belief in a series of perfect concentric crystal spheres with humanity at the absolute middle, is a beautiful, fragile lie. The weight of this truth is heavy and dangerous. To speak of a moving Earth or a decentralized cosmos is to challenge the very foundations of power and faith that hold the world together. Galileo records his findings in a small pamphlet titled The Starry Messenger, a document that sends shockwaves through the halls of academia and the chambers of the Inquisition. This discovery cost men their freedom, their reputations, and in some cases, their lives. It marks the beginning of a long, arduous struggle between the evidence of the senses and the dogma of the past. The heavens are no longer a divine, unchanging realm of perfection. They are a mechanical, dynamic clockwork, governed by laws that can be measured, timed, and understood. The shattering of the crystal spheres leaves humanity in a larger, colder, and more mysterious universe than anyone had ever dared to conceive. For centuries following that cold Padua night, the human gaze remains tethered to the ground, peering through increasingly large and sophisticated lenses. The 17th century gives way to the 18th and 19th, and the blurry, hand-drawn sketches of Galileo are replaced by the detailed maps of astronomers like Giovanni Cassini and Christian Huygens. They find more moons, more rings, and more mysteries hidden in the depths of the outer solar system. Saturn reveals its golden ears, which are later understood to be a disk of ice and rock. The moons of the outer giants are named after the lovers and companions of the gods, yet they remain little more than flickering ghosts in the eyepiece, distant and untouchable. Astronomers categorize them by their brightness and their orbits, but their true natures remain locked away behind the tyranny of distance. The transition from the blurry to the tangible arrives with the dawn of the space age in the 20th century. The arrival of the first robotic emissaries marks a revolution as profound as the first look through Galileo's glass. In the late 1970s, the twin Voyager probes launch into the void, carrying with them the electronic eyes of humanity. As they approach the Jovian and Saturnian systems, the grainy, black-and-white photographs of the past are swept away by a flood of colour and detail. The 4 points of light seen in 1610 are suddenly revealed as distinct alien worlds. They are no longer just moons in the generic sense, They are landscapes of sulphur, ice, and ancient stone. The shock of the alien replaces the comfort of the familiar. We see for the first time the orange smog of Titan, the shattered ice of Europa, and the volcanic scars of Io. These are not the dry, cratered mirrors of our own moon that we expected to find. Instead, they are vibrant, terrifyingly beautiful places that defy every rule of geology we thought we knew. The blurry sketches of the Renaissance have become the high-resolution maps of a new frontier, and as we leave the inner circle of the Sun behind, we realise that the true exploration of the solar system has only just begun. The heavens have been dismantled, and in their place, we find a collection of worlds that are stranger and more alive than anything in our ancient myths. At the heart of this celestial theatre sits Jupiter, a colossus of hydrogen and helium so massive that it warps the very fabric of the space around it. To understand the worlds that orbit this giant, one must first understand the invisible architecture of gravity. In the Jovian system, gravity is not a distant, passive force. It is an active and tactile sculptor, a heavy hand that reaches across millions of miles to grip, squeeze, and mould the destiny of every object within its reach. This force is the primary engine of change, a source of energy far more potent in these dark reaches than the diluted light of the distant sun. It creates a landscape where the fundamental laws of geology are dictated not by the cooling of a core or the presence of an atmosphere, but by the relentless rhythmic tug-of-war between a master planet and its devoted followers. The three innermost large moons, Io, Europa, and Ganymede, are locked in a mathematical embrace known as orbital resonance. This is a precision dance of celestial mechanics where their paths are synchronized with the regularity of a master-crafted timepiece. For every single orbit that Ganymede completes around Jupiter, Europa completes exactly 2, and Io completes exactly 4. This alignment is not a mere coincidence of physics, it is a structural reinforcement of gravitational influence. As the moons line up in their orbits, they exert a collective pull on one another, tugging their neighbours out of perfectly circular paths and into slightly elongated elliptical journeys. This eccentricity is the catalyst for a process that turns solid rock into something fluid and alive. As these moons move through their elliptical orbits, their distance from Jupiter is constantly changing. When they are at their closest point, the massive gravitational grip of the planet intensifies, pulling on the near side of the moon with significantly more force than on the far side. This creates a tidal bulge, a physical stretching of the moon's entire body. As the moon moves further away, the grip relaxes, and the body snaps back toward its original shape. This constant cyclical deformation is a source of immense internal friction. One can see this most clearly through the metaphor of a master blacksmith at his forge. If a blacksmith takes a cold rod of iron and strikes it repeatedly with a heavy hammer, the kinetic energy of the blow is converted into heat. Even without the presence of a furnace, the iron will begin to glow a dull, angry red as the atoms within the metal are forced to rub against one another. In the Jovian system, Jupiter is the anvil, the neighbouring moons are the hammers, and the satellites themselves are the metal being forged. This tidal heating is so powerful that it creates a thermal gradient across the system, dictating the character of each world based on its proximity to the giant. The closer a moon is to the centre of this gravitational furnace, the more intense the hammering becomes. This energy must go somewhere. It cannot be contained. It manifests as heat that liquefies rock, sustains hidden oceans, and drives the most spectacular geological displays in the known universe. It is a form of energy that bypasses the need for sunlight, proving that a world can be geologically and perhaps even biologically active in the deepest, coldest shadows of the outer solar system. This invisible architecture creates a spectrum of worlds, each a unique response to the sculptor's hand. Closest to the giant is Io, a world so violently hammered that its very interior has been turned into a roiling cauldron of molten stone. It is a place of perpetual eruption, where the crust is constantly being recycled by the sheer magnitude of the tidal forces. Just beyond lies Europa, where the balance of forces is more delicate. Here, the heat is not enough to melt the entire world into a volcanic hellscape, but it is sufficient to maintain a vast, liquid ocean beneath a protective shell of ice. It is a world of potential, a hidden sanctuary where the energy of gravity provides a substitute for the warmth of a star. Further out still is Ganymede, the largest moon in the solar system, a world so big it possesses its own magnetic field. Here, the tidal forces are weaker, yet they still provide enough energy to differentiate the moon's interior, creating a complex layered structure of ice and rock. Finally, there is Callisto, the outlier. Positioned far enough away from the resonance of its siblings, Callisto escapes the most brutal strokes of the gravitational hammer. It remains a frozen relic, a dark and cratered witness to the ancient past, its surface a graveyard of impacts that have never been erased by the internal fires of its neighbours. Through the lens of gravity, we see that these moons are not random collections of matter, but a carefully graded sequence of environments, each shaped by the relentless, rhythmic heartbeat of the Jovian system. The stage is set for a closer look at the first of these tortured landscapes, where the fire of gravity burns brightest. Io is the first victim of this gravitational warfare, a world caught in a vice of such titanic proportions that its very existence is a testament to the power of celestial mechanics. Positioned at the inner edge of the Galilean retinue, it is the focus of a relentless assault. On one side, the immense mass of Jupiter pulls with a force that threatens to tear the moon asunder. On the other, the synchronized tugs of Europa and Ganymede provide a rhythmic counterpoint. The result is a body that is never at rest. The solid crust of Io does not remain still. It heaves and subsides, rising and falling by more than 30 meters with every single orbit. This is not the subtle shifting of tides in an ocean of water, but the visceral, violent movement of solid rock, behaving like a living, breathing organism under extreme duress. This constant cycle of stress generates a level of internal heat that defies the expectations of the cold outer solar system. Deep within its belly, the friction of rock rubbing against rock turns the interior into a roiling sea of molten silicate. Io is not a dead rock drifting in the dark. It is the most geologically active object in the known universe, a place where the ground is a stranger to itself, perpetually being turned inside out. There is no ancient history recorded on its surface in the form of impact craters. Any scar left by a passing comet or asteroid is quickly erased, swallowed by the relentless engine of the moon's own making. The surface of Io is a fresh wound, a landscape that is being remade every few thousand years by a volcanic fury that never sleeps. The visual manifestation of this internal torment is a mottled tapestry of chemical violence. From the vantage point of space, Io does not resemble the silver-white of our own moon, or the blue-green of Earth. Instead, it is a world painted in shades of garish yellow, bruised red, and obsidian black. These are the colours of sulphur in its many forms, a chemical element that defines the moon's identity. Great lakes of molten sulphur simmer across the plains, while vast calderas, some spanning hundreds of kilometres, act as the vents for the pressure building below. When the pressure becomes unbearable, the moon screams. Volcanic plumes, driven by the expansion of sulphur dioxide gas, erupt from the surface with a ferocity that is difficult to comprehend. These fountains of fire and ash do not merely flow, they blast upward, breaching the thin, tenuous atmosphere and climbing hundreds of kilometres into the airless vacuum of space. Because there is no wind to disperse them, and little gravity to hold them back, these plumes take the shape of giant, translucent umbrellas, visible against the blackness of the void. As the material reaches the apex of its journey, it cools rapidly, transforming from a searing gas into a fine, crystalline dust. This sulphurous snow then begins its long, silent descent, falling back to the surface to coat the landscape in a fresh layer of frost. This cycle of eruption and deposition creates a world of surreal beauty and absolute hostility. The ground is a treacherous mosaic of cooling lava flows and treacherous sulphur flats. In some regions, the heat is so intense that the very rock glows with a fierce infrared radiance. While just a few kilometres away, the temperature drops to a level that would freeze the very air of Earth into a solid block. There is no stability here. A mountain that stands tall today may be undermined by a new flow of molten stone tomorrow, collapsing into a new caldera that will, in turn, become the site of a future eruption. Io's influence extends far beyond its own tortured surface. As it moves through its orbit, it carves a path through the intense magnetic field of Jupiter. The volcanic gases escaping from the Moon are stripped of their electrons by the harsh radiation environment, becoming ionized and trapped within the planet's magnetosphere. This creates a vast glowing donut of plasma known as the Io torus, a structure that links the Moon to its master planet in a permanent electrical embrace. Millions of amperes of current flow along these magnetic lines, sparking permanent auroras in the polar regions of Jupiter. Io is not just a moon. It is a power plant, a celestial engine that feeds the electromagnetic fury of the gas giant itself. To stand on the surface of Io would be to witness the raw, unshielded power of the cosmos. The sky would be dominated by the looming striped mass of Jupiter, a presence so large it would fill the horizon, its clouds swirling in a silent, eternal storm. The ground beneath one's feet would tremble with the heartbeat of the tides, and the horizon would be punctuated by the constant silent plumes of 100 active volcanoes. It is a world of fire born from the cold grip of gravity, a place where the rules of the inner solar system are burned away. Yet, as we move outward from this volcanic hellscape, the fire begins to recede, giving way to a different kind of mystery. The heat of the tides remains, but its expression changes from the scream of sulphur to the silent, dark depths of a hidden sea. The transition from the fires of Io to the ice of Europa is a journey from the visible to the concealed, from the fire of destruction to the potential cradle of life. The sulphurous yellows and bruised reds of Io recede into the blackness, replaced by a world of blinding alabaster purity. This is Europa, a moon that at first glance appears as a serene and frozen pearl, yet upon closer inspection reveals a face of exquisite and terrifying complexity. The surface is not a smooth expanse of snow, but a shattered stained glass window, a chaotic mosaic of ice that has been broken and refrozen over countless eons. Long intersecting ridges known as lineaments crisscross the globe like the veins of a titan, stretching for thousands of kilometers. These fractures are stained with deep rust-colored hues, a mixture of salts and complex organic compounds that have seeped through from the hidden world below. These red scars are the signatures of a moon that is leaking its secrets into the vacuum, a world where the exterior is merely a protective shell for a far more profound reality. Beneath this shell of ice, which spans a thickness of 20 or perhaps 30 kilometers, lies an environment that challenges our very understanding of where life can take hold. The ice here is not the soft, yielding substance found on a winter pond. At these temperatures, it is as hard as granite, a tectonic plate of frozen water that grinds and shifts under the relentless gravitational pull of Jupiter. Yet, as one descends through this frigid crust, the temperature begins to rise. The tidal friction that fuels the volcanoes of Io is present here as well, but in a more tempered form. It provides just enough energy to melt the lower reaches of the ice, creating a global subsurface ocean that encompasses the entire moon. This hidden sea is a body of water of staggering proportions. While the Earth is a world defined by its oceans, our seas are but a thin film, a delicate blue veil draped over the surface of a rocky planet. On Europa, the water is contained within a deep pressurized abyss that reaches depths of 100 kilometers or more. When the volumes are measured, this single small moon is found to harbor more than twice the liquid water contained in all the basins of Earth combined. It is a world of water, a dark and silent empire that has existed in total isolation for billions of years, shielded from the lethal radiation of Jupiter and the freezing vacuum of space by its overhead canopy of ice. The true wonder of Europa lies at the very bottom of this lightless ocean, where the water meets the rocky mantle of the moon. In the absolute darkness of the seafloor, the pressure is immense, yet the environment is far from stagnant. Here, the same tidal forces that stretch the crust also act upon the rocky interior, potentially driving volcanic activity on the ocean floor. We see the possibility of hydrothermal vents, cracks in the crust where superheated, mineral-rich water screams into the cold brine of the deep. On Earth, such vents are oases of life, teeming with complex ecosystems that have no need for the sun, relying instead on the chemical energy provided by the planet itself. This realization shifts the paradigm of the habitable zone. For centuries we believed that life required the warmth of a star, a narrow band of distance where water could remain liquid on a planetary surface. Europa suggests a different path. It proposes that life could thrive in the dark, fueled by the rhythmic heartbeat of gravity and the chemistry of a rocky core. The interaction between the mineral-rich floor and the saline water creates a chemical soup, a laboratory of the complex where the building blocks of biology, carbon, nitrogen, and phosphorus, are constantly being churned and mixed. It is a setting ripe for a second genesis, a biological beginning that owes nothing to the light of the sun. The sky of this world is a ceiling of ice, 10 kilometers thick, a permanent barrier between the dark waters and the stars. There is no weather here, no seasons, only the slow eternal circulation of currents and the faint rhythmic groaning of the ice shell as it responds to the giant planet above. To exist in such a place would be to inhabit a universe of sound and chemistry rather than sight. The red salts seen on the surface are the messengers of this deep world, brought upward by the churning of the ice, offering us a tantalizing taste of the chemistry within. If life exists within the dark heart of Europa, it would be a testament to the resilience of the biological impulse. It would mean that the universe is not a vast empty desert with a single, lonely oasis, but a garden where the seeds of life are scattered in the most unlikely of places. The fires of Io represent the raw power of the Jovian system, but the ice of Europa represents its potential for mystery. As we move further out into the realm of the ringed giant, we find that this theme of hidden depths and strange chemistries only intensifies. The story of the moons is a journey from the obvious to the obscure, from the fire that destroys to the water that sustains, leading us toward a world where even the air itself is a thick organic haze, hiding a landscape that is a distorted mirror of our own. The traveller leaves the Jovian realm behind, crossing a cold and silent expanse that stretches for hundreds of millions of miles. Ahead, the crown jewel of the solar system emerges from the dark, Saturn. It is a world defined by its rings, a vast shimmering disk composed of billions of shards of near-pure water ice, ranging from the size of a grain of sand to the proportions of a mountain. This halo of frozen debris reflects the pale sunlight with a brilliance that masks the complexity of the moons, orbiting within and beyond the rings. Among this sprawling family of satellites, one stands out as a titan in both name and nature. This is Titan, a world so large it rivals planets, and so complex it possesses an identity unlike any other moon in the cosmos. As the traveller approaches, Titan does not reveal its surface. Instead, it presents an unbroken veil of tangerine haze, a thick and opaque shroud that completely hides the landscape from the prying eyes of the universe. This is an atmosphere of staggering proportions, composed primarily of nitrogen, much like the air of Earth, but laced with a critical and transformative ingredient, methane. This gaseous mixture creates a pressure at the surface that is 50% higher than the pressure at sea level on our homeworld. It is a heavy, visceral atmosphere, a blanket of organic smog that traps the faint heat of the interior and creates a world of perpetual twilight. The story of our first true look beneath this veil is the story of the Huygens probe, a small, courageous emissary that journeyed across the void to pierce the orange gloom. In the early weeks of 2005, this machine separated from its mothership and plunged into the Titanian sky. The descent was not a swift fall, but a slow, drifting journey that lasted for more than 2 hours. The air was so dense, so thick with the weight of its own chemistry, that the probe's parachute struggled against a medium that felt almost like a liquid. As it descended, the probe captured the sounds of the wind and the shifting light, recording a transition from the high-altitude haze to a clear, cold, lower atmosphere where the features of the world finally began to sharpen into view. High above the surface, in the upper reaches of this nitrogen empire, a silent chemical forge is at work. Even though the sun is a distant and weakened spark, its ultraviolet photons still possess enough energy to strike the methane molecules, severing their atomic bonds in a process of photodissociation. These broken fragments do not remain solitary. They collide and recombine, forming increasingly complex chains of carbon and hydrogen. They become ethane, propane, and acetylene, eventually clumping together into heavy organic aerosols known as tholins. These particles drift downward through the atmosphere like a persistent microscopic soot, a slow-motion rain of organic matter that has been falling for billions of years. This process turns Titan into a planetary-scale laboratory for the building blocks of life, a place where the basic ingredients of biology are manufactured in the sky and deposited upon the ground. The physical reality of this environment is a paradox of gravity and density. On Titan, the pull of the world is weak, only about 1/7 of the gravity we experience on Earth. Yet the air is 4 times more substantial. This combination rewrites the laws of movement and flight. In the thick, cold air of Titan, the effort required to stay aloft is drastically reduced. A human being, if protected from the biting cold of nearly 300 degrees below zero, could strap simple, cardboard membranes to their arms and achieve true, powered flight. By merely flapping their limbs, they could push against the heavy nitrogen atmosphere and rise into the orange sky, soaring over the frozen landscape with the ease of a bird. It is a world where the very air provides a buoyant support, a viscous medium that turns the sky into a navigable ocean. As the Huygens probe neared the end of its 2-hour descent, the orange gloom gave way to a landscape that looked hauntingly familiar, yet fundamentally alien. It saw drainage channels, riverbeds, and shorelines, all carved into a surface of rock-hard water ice. But the liquid that shaped these features was not water. In the extreme cold of the Saturnian system, water plays the role of stone, while methane and ethane take on the role of liquid. The traveller, looking through the eyes of the probe, sees a world where the hydrological cycle of Earth is replicated with a terrifying hydrocarbon twist. The soot from the upper atmosphere settles into the valleys, forming vast dunes of organic sand, while the methane rains down to fill the depressions in the crust. The stage is set to explore this distorted mirror of our own world, a place where the rivers flow with fuel and the lakes are filled with the cold, dark essence of a different kind of chemistry. The surface of Titan reveals itself as a haunting, distorted mirror of our home, a world where the familiar rhythms of geology and meteorology are performed by an entirely alien cast of characters. Here, the very foundations of the landscape are built upon a paradox. The mountains, ridges, and vast rolling plains are not composed of silicate rock or volcanic basalt, but of water ice frozen to a degree of crystalline hardness that rivals the granite peaks of the terrestrial continents. In the staggering cold of nearly 300 degrees below zero, ice loses its fragility and becomes the bedrock of the world, a stubborn and unyielding mineral that forms the bones of the Titanian crust. This ice rock is carved, shaped, and eroded by a force that is eerily reminiscent of Earth's own hydrological cycle. Yet the liquid performing this work is a substance that would, on our world, be a volatile gas. Methane and ethane, the simple hydrocarbons that power our industries, are the lifeblood of Titan. In this frigid environment, they exist in a state of delicate equilibrium, transitioning between gas, liquid, and solid just as water does on Earth. The traveller witnesses a sky of heavy tangerine clouds that occasionally break into torrential downpours. This is not a gentle mist, but a heavy, slow-motion rain of liquid methane, falling through the dense nitrogen air in droplets larger than any seen on Earth. This rain gathers in the highlands of ice rock, forming trickles that grow into streams, and streams that merge into great rushing rivers. These veins of liquid fuel cut through the frozen landscape, carving deep canyons and winding through valleys with a relentless erosive power. As these rivers descend toward the lowlands, they carry with them a dark sediment of organic soot, the tholins that have rained down from the upper atmosphere. This material is deposited at the river mouths, forming vast, intricate deltas that fan out into the still reaches of the great northern seas. The largest of these, known as Kraken Mare, is a body of liquid methane and ethane so expansive that it dwarfs the Great Lakes of North America and rivals the Caspian Sea. It is a dark, glassy expanse that stretches toward the hazy horizon. its surface occasionally stirred by the thick, slow winds of the nitrogen atmosphere. Along the shores of Kraken Mare, the scene is one of profound, alien tranquility. The waves that lap against the coast do not crash with the energetic spray of the Atlantic. Instead, they move with a heavy, viscous grace, rising into low, gentle swells that ripple across the liquid gas. The beaches are not made of quartz sand, but of frozen hydrocarbons and grains of water ice, polished smooth by the eternal movement of the sea. Above this dark coastline, the sky is a permanent ceiling of orange gloom, where the sun is reduced to a pale, indistinct disk that provides no warmth, only a ghostly, diffused light that casts no sharp shadows. The familiarity of this world is its most unsettling quality. One sees the same patterns of drainage, the same evidence of seasonal flooding, and the same coastal processes that define the geography of Earth. Yet, the chemical reality is a total inversion. It is a world where the stones are made of frozen water, and the water is a flammable liquid. This mirror image geography suggests that the processes of a planetary surface, the movement of fluids, the erosion of mountains, the formation of weather, are universal laws of physics that can be executed by any substance given the right conditions of temperature and pressure. Titan is a testament to the versatility of nature, a place where the building blocks of a world are rearranged to create a landscape that is both recognizable and utterly unreachable. In the deep basins of the Titanian seas, the chemistry becomes even more complex. Beneath the liquid methane, the pressure and the presence of organic molecules create a chemical soup that some scientists believe could support a form of life entirely different from our own, a biology that uses hydrocarbons as a solvent instead of water. This would be a life of the extreme cold, moving at a glacial pace, fueled by the slow rain of energy from the orange sky. The reflection in the mirror is not just one of geography, but perhaps of biology as well, suggesting that the definition of a habitable world is far broader than the narrow, sun-drenched experience of the inner planets. As the gaze shifts away from the vast, dark seas of Titan, the scale of the Saturnian system offers yet another surprise. While Titan represents the complexity of a world with an atmosphere and a liquid cycle, there are other moons nearby that achieve the impossible through much simpler means. Leaving the orange haze behind, the traveller moves toward a tiny, brilliant speck of light that defies its own small stature. It is a world of pure white, a moon that should be a dead, frozen ball of ice but instead acts as a cosmic fountain, spraying the secrets of its hidden interior into the very rings of Saturn. The transition from the heavy, organic complexity of Titan to the crystalline purity of Enceladus is a reminder that in the outer solar system, every moon is a unique experiment in the survival of activity against the encroaching dark. Enceladus appears as a brilliant, blinding speck against the velvet black of the Saturnian suburbs. It is a world of near-pure water ice, reflecting almost 100% of the pale sunlight that reaches it, making it the most reflective body in the entire solar system. By every law of planetary evolution established in the inner solar system, this tiny sphere, barely 500 kilometers in diameter, should be a frozen, geologically dead relic. Its small mass should have allowed its internal heat to leak away into the void eons ago, leaving it as nothing more than a silent, cratered fossil of the early cosmos. Yet as the traveller draws closer to the southern hemisphere, the expected silence of a dead world is replaced by a display of celestial power that defies every conventional expectation. At the south pole of this frozen pearl, the smooth, ancient plains give way to a fractured and tortured terrain that speaks of immense internal pressure. 4 massive parallel fissures, each stretching for over 130 kilometers, scar the surface like the claw marks of a great beast. These are the tiger stripes. They are not mere cracks in the ice, they are active, thermal vents that glow with a heat radiating from the moon's hidden heart. Along these fractures, the temperature rises significantly above the surrounding frozen wastes, a clear signal that the interior of Enceladus is still churning, fueled by the same relentless tidal stretching that governs the larger moons of the giants. The pressure from the depths becomes too great for the icy crust to contain, and the moon finds its release in a spectacular ongoing eruption. From the dark recesses of the tiger stripes, plumes of water vapor and microscopic ice grains blast upward with the force of 1,000 geysers. These are not the fleeting steam vents of a terrestrial spring. They are supersonic jets that scream into the vacuum, climbing hundreds of kilometers above the surface in a continuous, ethereal fountain. Because the gravity of Enceladus is so weak, much of this material escapes the Moon's grasp entirely. It enters into a wide orbit around Saturn, spreading out to form the vast, ghostly E-ring, a sprawling halo of ice dust that owes its entire existence to the tireless activity of this single small moon. Enceladus is a cosmic fountain, a world that is literally turning itself inside out and sharing its substance with the ringed giant it serves. In a moment of supreme scientific daring, the Cassini spacecraft was commanded to dive directly through these plumes, a maneuver that transformed our understanding of the habitable universe. As the metallic explorer swept through the frozen spray, only a few dozen kilometers above the jagged ice, its instruments feasted upon the chemical bounty of the eruption. It did not find mere water, it detected a complex and tantalizing signature of potential life. The sensors recorded the presence of simple and heavy organic molecules, the carbon-based building blocks that form the foundation of all known biology. It found salts, indicating that the liquid water had been in long-term contact with a rocky core, and it detected tiny grains of silica, a definitive fingerprint of hydrothermal activity. This evidence points toward a single, staggering reality. Beneath the blinding white crust of Enceladus lies a global ocean of liquid water, kept warm by the friction of the tides and enriched by the minerals of a rocky seafloor. It is a world where all the requirements for life as we know it, liquid water, essential elements, and a source of chemical energy, are present in a stable, long-lived environment. Unlike the moon Europa, where the ocean is locked beneath a shell of ice tens of kilometers thick, Enceladus is actively delivering its secrets to the stars. It is spraying the contents of its hidden sea into the void, inviting the traveller to witness the possibility of a second Genesis without the need for a single drill or a complex landing. The realization is profound and humbling. We no longer have to search for the signs of alien biology in the distant reaches of other star systems. The ingredients for life are being offered to the vacuum, drifting in the cold light of Saturn. Enceladus, a world that should have been a silent ghost, has become a beacon of hope and a testament to the resilience of activity in the dark. It suggests that the universe is far more generous with its mysteries than we ever presumed, providing oases of potential in the most unlikely of places. As we leave this brilliant fountain behind, we carry with us the knowledge that the dark moons are not just cold outposts, but potential cradles, waiting for the moment when we are ready to understand what they have been whispering into the silence of space for 4 billion years. The story of the moons is no longer one of mere geology, but of the persistent driving force of a universe that seems to want to be alive. The story of our presence in the outer solar system is inseparable from the machine that became our surrogate, a metallic pioneer that transformed the ringed majesty of Saturn from a distant curiosity into a familiar neighborhood. For 13 years, the Cassini spacecraft acted as the eyes and ears of humanity, weaving an intricate and perilous dance through the Saturnian system. This was not a fleeting visit, but a long-term residency, a mission that saw children grow into adults, and scientists spend the entirety of their professional lives waiting for the slow, rhythmic pulse of data to travel across the void. The distance between the laboratory and the explorer was immense, often exceeding 1 billion miles, a gap so vast that even light required over an hour to bridge it. This lag created a strange, ghostly connection. The scientists were always looking into the past, reacting to events that had already occurred, guided by an umbilical cord of radio waves that stretched across the silent gulf of the solar system. The bond between the human creators and their robotic creation was forged in the fires of shared discovery. Every image of Titan's methane lakes and every reading of the plumes of Enceladus was a victory won through decades of planning and years of patient observation. The spacecraft was more than a collection of spectrometers, cameras, and thrusters. It was an extension of the human nervous system. When Cassini felt the buffeting of Saturn's magnetosphere, or the gentle drag of a moon's gravity, the scientists in their darkened rooms on Earth felt it too. They learned the temperament of the machine, its quirks and its resilience, as it survived the intense radiation and the constant threat of dust particles within the rings. It was a partnership that redefined the boundaries of what it meant to be an explorer, proving that the human spirit could inhabit a vessel of titanium and silicon just as easily as one of flesh and bone. As the mission entered its final phase in the year 2017, the team faced a bittersweet necessity. The spacecraft was running low on the propellant needed to adjust its course, and the very discoveries it had made now dictated its destruction. By revealing the tantalizing potential for life within the hidden oceans of Enceladus and the organic chemistry of Titan, Cassini had made those worlds sacred. To allow the machine to drift aimlessly after its power failed was to risk a future collision that might contaminate those pristine environments with terrestrial microbes. The laws of planetary protection demanded a sacrifice. The explorer that had spent 13 years revealing the beauty of the Saturnian system would have to die to ensure that the potential for life on its moons remained untainted. The final act, known as the grand finale, was a display of supreme navigational virtuosity. Cassini was commanded to perform a series of 22 daring dives into the unexplored gap between Saturn's innermost rings and the planet's upper atmosphere. It was a region of space no machine had ever dared to enter, a narrow corridor of mystery where the spacecraft could taste the very edge of the giant's clouds. With each pass, it gathered data on the mass of the rings and the internal structure of the planet, sending back information until the very last moment. Then, on a cold September morning, the final command was executed. Cassini turned its high-gain antenna toward Earth for the last time and plunged into the crushing depths of Saturn. The descent was swift and absolute. As the spacecraft hit the upper layers of the atmosphere, it fought to keep its antenna pointed toward the distant spark of home, its thrusters firing at maximum capacity to maintain the link. For a few brief minutes, it became a meteor, a man-made star streaking across the Saturnian sky. The friction of the hydrogen and helium quickly turned into a searing heat, and the machine that had survived 13 years in the frozen dark was incinerated. Its components vaporized and scattered into the clouds of the giant it had studied for so long. In the mission control centers on Earth, the signal simply vanished. A flat line on a monitor marked the end of an era, followed by a silence that was heavy with the weight of 1 billion miles and over a decade of devotion. The legacy of this sacrifice is a fundamental rewriting of the cosmic map. Cassini proved that the habitable zone, the region of space where life might find a foothold, is not a narrow band governed solely by the warmth of a star. By uncovering the energy of the tides and the chemistry of the dark moons, the mission demonstrated that the universe is far more hospitable than we once dared to believe. It showed us that life does not need the sun to thrive if it has the rhythmic heartbeat of gravity to sustain it. The machine is gone, its atoms now part of the very planet it orbited, but the data it returned remains a golden record of a time when humanity reached across the abyss to touch the face of the giants. We are left with a new understanding of our place in the cosmos, realizing that the dark, cold moons of the outer solar system may be the true homes of the universe, and that our journey into the silent reaches has only just begun. The traveller pushes further still, crossing the final threshold of the planetary empire to reach the cold, sapphire majesty of Neptune. At a distance of nearly 3 billion miles from the Sun, the light of the star is reduced to a mere 400th of its strength on Earth, casting a ghostly perpetual twilight over the deep outer system. Here, the dominant presence is not the planet itself, but its largest companion, Triton. This is a world that defies the established order of the cosmos, a moon that serves as a stark reminder that the history of the solar system is one of chaos and celestial theft. Triton is not a native of this realm. It did not form from the swirling disk of gas and dust that birthed Neptune. Instead, it is a captured wanderer, a former citizen of the Kuiper Belt that was snared by the giant's gravitational trap billions of years ago. The evidence of this violent history is written in the very geometry of its path. Triton is the only large moon in the solar system that orbits in a retrograde motion, moving in a direction exactly opposite to the rotation of its parent planet. To observe its movement is to see a clock running backward in a universe that otherwise demands a synchronized forward momentum. This defiance of the natural order is the hallmark of a kidnapped world, a body that was once a twin to Pluto, drifting in the dark before being pulled into a permanent terminal embrace by the blue giant. This capture would have been a cataclysmic event, a gravitational struggle that likely cleared out Neptune's original family of moons, leaving Triton as the undisputed yet doomed master of the system. The surface of Triton is a landscape of extreme and fragile beauty, a place where the temperature hovers at nearly 400 degrees below zero. It is a world of frozen nitrogen, a substance that on Earth is the very air we breathe, but here is a solid, shimmering crust. The landscape is dominated by what astronomers call cantaloupe terrain, a vast wrinkled expanse of pits and ridges that resembles the skin of a melon, created by the slow internal churning of ices. Despite the staggering cold, Triton is far from dead. It possesses a thin, tenuous atmosphere of nitrogen, and its surface is marked by a phenomenon that speaks of a hidden internal energy. Across the frozen plains, dark geysers erupt into the lightless sky. These are not the water-driven fountains of Enceladus, but plumes of nitrogen gas and black organic dust that blast upward from beneath the nitrogen ice. Driven by the faint warmth of the sun, or perhaps the moon's own internal heat, these jets scream into the vacuum, reaching heights of 8 kilometers before being caught by the high-altitude winds. They form long, dark streaks across the white and pink ice, like soot scattered across a pristine snowfield. These geysers are the breath of a dying world, a final display of activity from a body that is slowly being consumed by the very planet that captured it. The metaphor of the backward-running clock extends beyond Triton's orbit and into its ultimate fate. Because the moon orbits in a direction opposite to Neptune's rotation, the laws of orbital mechanics act as a relentless brake. In the inner solar system, moons like our own are slowly being pushed away by tidal forces, but Triton is being pulled inward. It is caught in a death spiral, a slow-motion descent that brings it closer to Neptune with every passing century. This is a tragedy written in the language of gravity. In a few 100 million years, a mere blink in the eyes of the cosmos, Triton will reach the Roche limit, the point where the gravitational pull of Neptune becomes stronger than the internal forces holding the moon together. The end will be spectacular and absolute. As Triton crosses this invisible boundary, the giant planet will begin to tear the moon asunder, striping the ice and rock from its body in great terminal ribbons. The captured wanderer will be pulverized into 1 billion fragments, which will then spread out to form a magnificent shimmering ring system that will dwarf the glory of Saturn. Neptune, the lonely blue giant, will finally have a crown worthy of its stature, but it will be a crown fashioned from the bones of its most faithful companion. Triton is a temporary monument, a world whose existence is a brief, beautiful anomaly in the long history of the solar system. Reflecting on Triton is to reflect on the transience of all things. It is a world that was stolen from the dark, forced into a backward dance, and destined to be ground into dust. As the traveller looks back from the edge of the Neptunian system, the moons of the giants are seen not as permanent fixtures, but as dynamic, changing entities. They are the leftovers of creation and the precursors to new structures, caught in a cycle of birth, capture, and destruction. The story of the solar system does not end with the planets. It continues into the furthest reaches where the rules are broken and the clocks run backward, leading us toward a final contemplation of what remains when the lights of the Empire finally begin to fade. Beyond the blue veil of Neptune and the tilted, erratic system of Uranus lies the final frontier of our local planetary empire. Here the moons are not merely satellites, but unexplored archives of a chaotic and distant past. The 5 major moons of Uranus, Ariel, Umbriel, Titania, Oberon and Miranda, exist in a state of deep cryogenic isolation, their surfaces glimpsed only once by the fleeting eye of a passing robotic emissary. Miranda, perhaps the most enigmatic of them all, presents a face of geological madness. It is a world that looks as though it were shattered into 1,000 pieces by a titanic impact, and then roughly, haphazardly reassembled by the blind hand of gravity. It possesses cliffs that drop 20 kilometers into the dark, the tallest in the known universe, where a falling object would take over 10 minutes to reach the bottom. These worlds are the true outsiders, holding within their bruised and cratered rinds the chemical signatures of the primordial cloud from which the entire solar system was born. They are the cold, dark witnesses to the era when the giants migrated through the disk of debris, carving out the architecture of the heavens and scattering the seeds of the planets. Yet, the current arrangement of the solar system is merely a brief pause in a much longer and more transformative narrative. The Sun, currently a stable and reliable source of light, is a machine of finite fuel, and its current state is not a permanent condition. 5 billion years from now, the hydrogen in its core will be exhausted. The delicate balance between the inward pull of gravity and the outward pressure of nuclear fusion will fail, and the star will begin its final, grand metamorphosis. The core will contract and heat up to unthinkable levels, while the outer layers heave and sigh, expanding with a terrifying silent majesty. The Sun will swell into a red giant, a bloated and angry orb of crimson light that will fill the sky of the inner worlds. The sanctuary of the inner system will be erased. Mercury and Venus will be swallowed by the expanding solar atmosphere, their rocky bodies vaporized in an instant as they are dragged into the heart of the star. Earth, if it is not consumed, will be scorched into a lifeless cinder. Its oceans will boil away into space, its atmosphere will be stripped by the solar wind, and the very mountains will melt into rivers of glass. The cradle of humanity will become a wasteland. However, as the inner planets perish in this solar fire, a strange and fleeting opportunity arises in the outer reaches. The habitable zone, that narrow precious region where the warmth of a star allows for liquid water, will be pushed outward by the expanding furnace of the dying sun. For a few 100 million years, the cold, frozen moons of the gas giants will step out of the shadows. The ice of Europa will begin to thin and crack, eventually melting into a global ocean that's open to the sky for the first time in billions of years. On Titan, the thick nitrogen atmosphere will warm, and the rivers of liquid methane will evaporate, replaced by a brief era of liquid water and an atmosphere that might for a moment resemble the early Earth. The frozen deserts of the outer system will bloom with a warmth they have never known. These worlds, once defined by their absolute bone-crushing cold, will become the only temperate places left in a dying system, the final, fragile refuges for the legacy of the Sun. This will be a golden age of water in the outer dark, a brief window where the moons of Jupiter and Saturn become the centre of the solar system's biological potential. But this solar spring is a temporary grace, a fleeting transition in the star's journey toward the end. As the Sun eventually sheds its outer layers in a series of violent pulses, creating a planetary nebula that will glow like a ghost in the interstellar dark, its core will collapse into a white dwarf. This small, dense remnant will possess no more fuel to burn, and its light will begin a slow, trillion-year fade into blackness. The warmth that briefly touched the outer moons will vanish. The newly formed oceans of Europa and the rains of Titan will return to a deep eternal freeze, or perhaps the moons themselves will be scattered into the void as the gravitational grip of the dying star weakens. These worlds are not permanent monuments, but temporary structures in the long, unfolding history of the cosmos. They represent a moment in time, a specific alignment of matter and energy that is destined to change. We see them now in their frozen youth, but their future is one of fire and then a final, absolute cold. They remind us that the universe is not a static gallery of objects, but a process, a grand, unfolding drama where today's frozen outpost is tomorrow's tropical oasis, and eventually, a silent relic in a darkened neighbourhood. The transience of these worlds does not diminish their beauty. It heightens it, marking them as precious, fleeting characters in a story that began with a bang and will eventually end in a whisper. As the traveller looks back from the edge of the system, the realization settles in that even the giants and their retinues are but dust in the wind of deep time. temporary monuments to the power of a medium star in a vast and ancient universe. The Voyager spacecraft, a frail assembly of aluminum and gold, drifts across the invisible boundary where the influence of the Sun finally falters. It has crossed the heliopause, leaving behind the protective bubble of the solar wind to enter the true interstellar dark. Behind it, the Sun is now just one star among many, its light no longer a warm embrace but a distant cold memory. From this vantage point at the edge of the abyss, the traveller looks back at the system it has traversed for nearly 50 years. The great planets have shrunk into insignificance, their massive bulks reduced to flickering points of light, but the memory of their moons remains vivid and profound. These satellites are no longer the blurry specks that once baffled the early astronomers. They have become the central characters in an epic ancient drama that has played out over 4 billion years of cosmic history. In the long memory of our species, we see Io, the tortured dancer, perpetually burning in its own volcanic fire as it pays the price for its proximity to the giant. We see Europa, the silent keeper of secrets, guarding its dark, global ocean beneath a shield of ice that has never known the sun. We see Titan, the orange-shrouded mirror of our own world, where the rains of methane fall upon shores of frozen stone, and Enceladus, the crystalline fountain, spraying the very ingredients of life into the cold vacuum. Even Triton, the captured wanderer orbiting in defiance of the natural order, stands as a testament to the chaotic and beautiful history of the outer reaches. They are no longer mere afterthoughts of planetary formation. They are worlds in their own right, each possessing a unique identity forged by the relentless interplay of gravity, chemistry, and time. There is a deep, intrinsic attraction that draws the human spirit to these lonely outposts of ice and stone. We find a reflection of our own isolation in their silent orbits around different giants. We live on a planet teeming with life and noise, yet we often feel like solitary observers in a vast and uncaring cosmos. To look upon a moon like Europa or Enceladus is to see a reflection of our own struggle for existence against the encroaching dark. We find a strange comfort in the fact that even in the coldest, most remote corners of the solar system, the forces of nature conspire to create heat, liquid water, and the potential for a beginning. Our fascination with these worlds is a search for company, a desire to know that we are not the only spark of complexity in an otherwise empty theatre. We sent these robotic emissaries because our own bodies are too fragile for the journey, yet through them we have truly touched the face of the giants. Our curiosity is the tether that links us to these distant spheres, a bridge of radio waves and mathematics that spans the silent gulfs of space. We have mapped their craters, analysed their atmospheres, and tasted their plumes, and in doing so we have fundamentally expanded the definition of home. We realise now that the solar system is not just a collection of dead rocks, but a vibrant and interconnected web of environments, where the rules of life are being tested in a billion different ways. The silence of the outer system is not an absence of meaning, but a canvas upon which we have painted our highest aspirations and our most profound questions. The traveller continues its journey into the eternal night, moving toward the stars at tens of thousands of miles per hour, carrying with it the sounds and images of a world it will never see again. But the perspective it has granted us remains etched into our collective consciousness. We look out from the surface of a distant cratered world, watching as a small blue and white marble rises over the jagged frozen horizon. It is a fragile and heart-stopping sight, a tiny oasis of liquid and light suspended in the absolute blackness of the void. In this moment, the distinction between a planet and a moon dissolves. We see that we are all travellers on a small rocky satellite orbiting a medium-sized star in a galaxy of hundreds of billions of suns. We are part of the same ancient drama, governed by the same laws of physics and driven by the same urge to persist against the entropy of the universe. The moons of the giants have taught us that life does not require the centre of the stage. It can thrive in the wings, in the shadows, and in the deep, dark places where gravity provides the only warmth. As the signal from the farthest explorer grows faint, we are left with a sense of profound humility and renewed wonder. The heavens have been dismantled and rebuilt, and we find ourselves in a universe that is far more mysterious and far more hospitable than we ever dared to conceive. The screen of our understanding fades to black, yet the faint rhythmic hum of the cosmic microwave background remains, a reminder of the silence from which we came and the vastness to which we are all returning. As long as there is a moon in the sky, there is a mystery waiting to be solved, and as long as there are eyes to look upward, the story of the outsiders will continue to be told. We are no longer afraid of the dark, for we have found that even in the deepest shadows there is the persistent, quiet promise of something more. The journey does not end at the edge of the solar system. It is merely the beginning of our realization that we are part of a much larger family of worlds, drifting together through the ancient and beautiful dark.